Hello, and welcome to Fast Politics. I'm thrilled to welcome Charles Piller, an investigative journalist for sites like Science and the LA Times. He is the author of books like Gene Wars and the Failsafe Society, but today we're going to be talking about his new book, Doctored: Fraud, Arrogance, and Tragedy in the Quest to Cure Alzheimer's. Welcome, Charles.
Thank you for having me, Molly.
So this is a story of it's pharmaceutical companies gone wrong.
That's part of it, yes. And scientists.
And scientists go wrong. So explain to us the premise of this book and how you got started. Alzheimer's is, I think, of the sort of the worst of the worst. So talk to me about how you got involved in this story to begin with.
Sure. So as an investigative reporter, a lot of my stories come to me from tips from people who have read some of my other stuff and want to come forward and suggest ideas. This tip about Alzheimer's disease came from a very credible guy, a neuroscientist who is expert in this growing art of forensic image analysis, sometimes called image sleuthing.
Right.
And he's a guy who treats Alzheimer's patients and also has his own lab. His name is Matthew Schrag, Vanderbilt University. And he was looking at some Alzheimer's studies and ran across one that had been one of the most important basic science studies in the field for many years, highly regarded, highly cited in the scientific literature, and very influential. And what he found was that it was apparently based on doctored images.
Wow. So what happens from there?
So this began a period of about 3 years of conversations with Schrag and a lot of other people in the field. Obviously, it started down this path of trying to understand what is the extent and degree of importance of apparently doctored research in Alzheimer's disease. And the question is relevant because we have a disease that is so tragic and affects so many people, and yet there are no effective treatments. There's nothing on the market that arrests or reverses the symptoms of the disease. It's partly because it's a very, very tough problem to solve scientifically, but it's also because I've learned through my reporting that there have been certain studies that have been important in the thinking of scientists that were based on false data and that have skewed thinking in the field and directed scientists in areas that have not proved to be fruitful. And so the book and my discussions with Schrag, a lot of it has been on how do you look at these things critically? How do you assess their importance? And what is the meaningfulness of it in the field of Alzheimer's research?
So I just want to pause for a minute because isn't there a drug that sort of works on the amyloid plaque?
Yeah, there are a couple drugs that have come onto the market recently.
Yeah.
One is called Leqembi. That was considered kind of a big breakthrough drug.
Right.
And it is a drug that attacks amyloid plaques and other forms of amyloid in the brain. And these are the proteins.
Why don't you explain how amyloid is involved in Alzheimer's?
Sure. Actually, let me go back very briefly to the very beginning, the sort of first description of Alzheimer's disease by this guy, German scientist, Elwa Alzheimer, back in 1906. He had a patient who was suffering from terrible dementia. And after she died, he was also a pathologist, so he examined her brain after her death, and he found the presence of these two kinds of proteins. These amyloid plaques, these are the prototypical sticky plaques that people talk about, and also these proteins called tau, which are inside nerve cells, and they're kind of called the tangles, so plaques and tangles, the combination of that and dementia equals Alzheimer's disease. And so for a very long time, decades, not that much research was done into Alzheimer's, in part because of a simple demographic demographic reality, which is that not that many people were growing to the very old age that Alzheimer's characteristically starts to be a problem.
Right.
And so not until the 50s, 60s, 70s, when advances in vaccines and cancer treatments and heart disease began to extend lifespans, particularly in rich countries.
Right.
Did we see a great increase in Alzheimer's patients. And then a lot of effort was made into figuring out what's going on here. And by the early 90s, a hypothesis emerged called the amyloid hypothesis. And it's pretty simple to understand. It holds that the accumulation of these amyloid proteins in the brain lead to a cascade of biochemical effects that start to cause cell death and eventually dementia. And so this became the big prominent way of looking at the disease.
So I just want to pause here for a second. So part of what's happened here is that it was later onset. People were living late enough to get it, right? But sometimes Alzheimer's, as we know, comes earlier at 40s, 50s. It's unusual, but it happens, right? What percentage would you say?
Very small percentage, probably
Okay.
around 1% of all cases.
Oh, wow. So pretty
Yeah.
short, small.
Yeah.
So there was some of these doctored images. For a long time, they didn't even know that it was the amyloid plaque. I mean, even that discovery of the plaque in the 1900s, that still wasn't thought of as sort of the cause of Alzheimer's until later, right?
Well, it was formulated into this grand idea, the so-called amyloid hypothesis, only in the early 90s. And this had been after a lot of research into the derivatives of this protein and where it comes from. And scientists tried to, it was very logical. You see these amyloid plaques in someone's brain after they die from Alzheimer's disease. And it became this obvious target for drug development. And that was kind of the way in which people accepted this hypothesis as being the dominant way of looking at the disease.
Explain to us sort of where the corruption came from, what it looked like, and what it caused.
Okay. So going back to this moment when Matthew Schrag at Vanderbilt University noticed this important study in the field with these digital anomalies in some of the images that looked like image doctoring or a form of misconduct in science. Let me explain the context. So at that time in the early 2000s, so this paper was published in 2006 in this preeminent scholarly journal, Nature. So it was already a big deal to be published in that publication. And then it had enormous sway in the field. And for this reason, at that time, there had been some remedies developed based on the amyloid hypothesis. So these were drugs that attacked amyloid proteins and were pretty successful at removing them from the brain, but not at all successful in arresting or reversing the symptoms of Alzheimer's disease. And so what this experiment did in 2006 by scientists at the University of Minnesota, they had a very clever idea. What they did is they used genetically engineered mice that produced copious volumes of amyloid proteins that deposited in the mice brains. They extracted one certain kind of protein from that mix of amyloid proteins in the mice. And this was named amyloid beta star 56, their star protein. This is what goes for a catchy name in the scientific world. But it did grab some mind share and some interest in the community because their experiment was so clever. What they did is they refined this protein and then they injected their star protein into the brains of rats. And then very quickly, they saw that the rats were exhibiting signs of memory loss that they compared to the memory loss seen in Alzheimer's disease. So for the first time, you had a kind of cause and effect relationship. A particular substance was thought to be causing symptoms, albeit in animals, that are sort of like Alzheimer's disease. And this reinvigorated interest in the amyloid hypothesis in the scientific community. It made people think, okay, we haven't been successful yet in showing that this hypothesis was absolutely proven, but this is making us realize we're really on the right track. And enormous sums of money, enormous mind share in the scientific community, if you will, went directly into reinforcing this idea and thousands of experiments to be done in that realm. So that was why it was so important. what Schrag noticed was that, unfortunately, the basis of this experiment, the images that displayed the findings, appeared to be doctored. In other words, falsified by
Right.
the experimenters.
That's kind of amazing. Does that happen often? And talk us through why they did it.
To take the often part first, the answer is that in my book, Doctored, part of what I tried to do is to answer that question. And so I did something that has never been done before, which is I enlisted a group of forensic image sleuths, as they call themselves. One was Schrag, the guy I mentioned before, who was working in on his own time, not as part of his job at Vanderbilt. A woman by the name of Elizabeth Bick, who is the world's foremost, best known forensic image analyst in scientific imagery. A non-scientist by the name of Kevin Patrick, who's just very adept with these images and has amazing computer skills, and a scientist at Columbia University, Mu Yang. The four of them worked with me for more than a year to examine dozens and dozens of scientists in the field, including some very prominent Alzheimer's scientists, and found hundreds of studies that many of them were very influential studies in the field by top scientists in the field that were apparently based on doctored images, on falsified images. So
Oh,
we,
wow.
we knew that it was a big problem in the field, not just this one-off from this one study.
So were all these scientists doctoring their own images, or were they getting a hold of images that had been doctored?
Yeah, it's not always clear what the answer to that is because
Wow.
these are, science today, and especially these big lab experiments, it's a team sport. And so a lot of people have their hands on it, but you can kind of by process of elimination, in a sense, figure out who's most responsible. So when you have a scientist who is the primary author on dozens of papers that have been apparently doctored, and there are no other common authors on that paper, then it's logical to think that that person at least had a substantial involvement in the apparent doctoring of these images. And we were able to conclude that. I was able to conclude that from an enormous amount of work done by these forensic image analysts that I vetted very carefully, obviously with real experts in the field of Alzheimer's research.
This seems like a pretty big deal.
Yeah, I mean, I think it's problematic for the field because what we know is that many important studies in the field have been based on doctored images or the improper reuse of images over and over in different papers where they really don't show the actual results of an experiment. And it does not show that all research in Alzheimer's is somehow suspect, but it shows that the field, and I think science more generally, has a need and a responsibility to be less complacent about examining this and what the impact might be. Not all science is doctored, but like any field, like any walk of life, a certain small percentage of people are inclined to be dishonest and to promote their careers or to try to make money off of false actions, false science in this case. And as a community of the consumers of medications, as a way in which these papers are used in society, we need to demand that the institutional authorities do a better job at monitoring and ensuring that the information supply in science is more reliable.
This is a very big deal because it means that, how much do you feel of the Alzheimer's drug success may be called into question here?
My view is that the vast majority of research in Alzheimer's disease, like the vast majority of work done in all walks of life, is done honestly and with integrity.
Right.
People are trying to do their best. And I do not subscribe to the idea that because some research was falsified, that therefore all research is suspect. And this has been a bit of a false message that's been promoted by, I think, people who are cynical or even people who are critics of science more generally. And I think a lot of the stuff going on you see in Washington right now with Musk and Trump and his people slashing and burning scientific institutions, to me, that is incredibly wrongheaded and incredibly harmful. I don't subscribe to those ideas at all. But at the same time, I think it's really important to remember that we have a right to expect much better performance from the institutions of science that have been complacent, that have been negligent in their responsibility to detect fraud, to detect misconduct, and to ensure that the scientific record and work that goes in to the development of drugs is reliable. And they haven't been doing a good enough job in that.
Where does your story go from the falsified images to what to what?
Really, this story is trying to answer some big questions about Alzheimer's disease research. And one of them is, have we been over-reliant on one dominant way of thinking about the disease, this so-called amyloid hypothesis? And what I learned is that because this has been such a dominant way of thinking, because it has been showered with billions of dollars in development work, because unfortunately some of the thinking associated with it has been reinforced by unreliable, sometimes falsified drug studies and unreliable, sometimes falsified basic research, that there has been an over-reliance on it. And it has
Right.
crowded out other creative ways of thinking about how to solve the Alzheimer's puzzle. It does not mean that there's nothing about amyloid proteins to do with Alzheimer's disease. My view, and I think the view of even the great skeptics of this hypothesis, is that amyloid proteins have something to do with Alzheimer's disease. They just don't have everything to do with Alzheimer's disease. And
Yeah.
so
Oh,
we need to
you
think
really
creatively.
you don't think they have everything to do with Alzheimer's disease?
I do not. I do not.
Wow.
I think they
Mind
have.
blown.
Yeah,
Why?
well, in part because there are many contradictions in the hypothesis. One is that many people who have no symptoms of dementia lead normal lives well into old age, and then die and have their brains autopsied, show copious volumes of amyloid in their brains, even copious volumes of the so-called tau proteins, the tangles, and yet no signs of dementia. And so right off the bat, that's a confusion and a
Right.
complication in the
Right. Oh,
idea.
so you can have a brain that looks like you have Alzheimer's, but not have Alzheimer's.
Exactly right.
Wow.
You can die with your head full of amyloid proteins and no dementia. So that's
Wow.
contradiction number one.
Yeah.
Another contradiction is that there have been drugs developed, several drugs developed, a couple of which are now on the market, that are incredibly good at removing amyloid proteins from the brain of living people. Obviously, they're drugs.
I know
And,
someone, yeah.
and these drugs, as good as they are at removing the proteins, they have absolutely no ability to arrest or reverse the symptoms of Alzheimer's disease. So they're very good at examining the supposed cause of the disease and effectively treating it, but not good at treating the symptoms of the disease. Now, what they do, and I think people should understand this clearly, is that to a statistically measurable degree, they have been shown in clinical studies to have the effect of slightly slowing the cognitive decline of Alzheimer's disease. So right off the bat, you would think, okay, that's given that we don't have anything better, maybe that's a really good thing. And the answer to that question is a little bit more complicated. And let me put it in these terms. So if these drugs were totally safe and cheap, then even if they only had a minute effect on slowing the cognitive decline of the disease, they'd be something that I think almost everybody who had Alzheimer's would want to at least consider taking. But what you have is a situation where the benefit of drug is so minute that many neurologists, patients, and family members would say, and do say, that it's imperceptible. In other words, it's such a minor effect that you're not really even sure it's having an effect at all. But in addition, these drugs are extremely expensive. They cost tens of thousands of dollars per year per patient. And they are also potentially very dangerous. They can cause death in extreme cases from brain swelling or bleeding. And so they're a mixed bag, and not something that you think, well, we're at an end point. We've proven our point, and these are the great drugs we've been waiting for. Nothing like that.
Really interesting. Explain to us what you think sort of the next step where things should go with Alzheimer's and the drugs.
Great question, because I think there are a lot of really interesting creative ideas coming down the pike about Alzheimer's disease. So a couple of the things that I am fascinated by and I think are starting to get real attention. One is testing the GLP-1 inhibitors. These are the seemingly miraculous drugs used for obesity, diabetes, and are starting to be considered possible.
Mounjaro. That's like Mounjaro. Yeah.
Like Ozempic and
Yeah.
drugs like that. And they are, so much in demand for what we know they can do. They're being tested also for possible benefits for Alzheimer's patients. Even as soon as next year, we may have concrete information from clinical trials about whether they might have a beneficial effect on dementia. So that's one I'm looking at quite closely. Another is that it's increasingly thought that infections may be a cause of or an influence on Alzheimer's dementia. And for example, herpes virus, which people may recall causes cold sores that resolve, but people may not know that it tends to hang out in internal organs for years or even decades after the infection seems to have gone away. And the brain is one of those organs that you can find herpes virus in. And they're now experimenting with treating that virus in people who have early dementia and seeing whether it could have a beneficial effect on the disease. And there's a lot of promising lab studies that have shown that there's reason to believe that it might be a beneficial treatment. So that's one that I'm really looking forward to hearing the results of in the next 2-3 years. So those are two areas that have nothing to do with the amyloid hypothesis, that had historically not gained a lot of street cred, if you will, in the scientific world, that are now being studied much more carefully, and I think with potentially great benefit. Also, Molly, if you don't mind, I'd just like to mention that I think people sometimes don't realize that even though there's no brain game or supplement or good dietary practice or fitness routine that will prevent Alzheimer's disease, we do have some agency over ourselves and the possibility that we might have severe Alzheimer's symptoms if we're unlucky enough to get that disease. And that's because high cholesterol, high blood pressure, poor eating habits, unhealthful eating habits, sedentary lifestyles, things like that are all potential risk factors for the disease. And if we just try to live our best lives and be conscientious about our health, we actually can have an effect on forestalling the worst symptoms of the disease. So while I say there is no anything that you can do personally that absolutely prevents Alzheimer's, you can benefit yourself and in general sense, and also with regard to contracting Alzheimer's late in life. So I would just encourage people to think about that and not feel hopeless about it.
Thank you.
Thank you so much for your interest in this, Molly.